8.4 homework. Let's give it a shot. All right, so remember we're dealing with rates, so write your name and write your period, whatever it is. All right, so we are revisiting the stair jumping problem that was in the opener. Dylan and Austin are brothers. Again, not important. They play a racing game on the stairs. Okay, so they're racing. In the game, they jump up the stairs, landing on 2 feet each time. When Austin jumps, he lands on each step. So Austin, let's pull that out. Austin, each step. When Dylan jumps, he skips the steps and lands on every other. So Dylan, every other step. Okay, so we pulled that information out. Let's see what we got. When Dylan jumps up the staircase, how many jumps does he make? Well, Dylan does every other step. So this must be Dylan. So this is 1, 2, 3, 4, 5 jumps. All right, when Austin jumps up the staircase, how many jumps does he make? So this has to be Austin because it's every step. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 jumps. If Austin and Dylan each took 5 jumps, who would be further in the stairs? Well, at 5 jumps, we just said Dylan's all the way here. And Austin's only 1, 2, 3, 4, 5. So Dylan would definitely be further. At the end of the race, who took fewer jumps? Well, Dylan had to do 5 jumps. Austin had to take 10 jumps. So at the end of the race, who took fewer jumps? That's 5 jumps for Dylan. Dylan's going to get there faster because he gets to skip a step each time. Who do you think won the race? Dylan, because he jumped 2 stairs every time. Austin had to actually jump every single time. He's not skipping stairs. All right, part 2. Traveling on a trip. So immediately we're starting to travel. Suppose your family is taking a road trip of 120 miles to visit a relative. So 120 miles is the entire thing that we have to go, the entire trip. Complete the table how long it would take to show how long it would take to complete the trip for different speeds. So here's the speed, here's the time. We know that X is always there and Y is there. So X is going to be my speed. Let's double check our graph. Is X speed? Yes. Y, time to complete the trip in hours. Y-axis, time to complete the trip in hours. Okay. So if we drove 60 miles an hour, time to complete this trip. Well, if I drove 60 miles an hour, I'd have to go 120 miles, so that's 2 hours. If I drove 40 miles an hour, 1 hour is 40 miles, 2 hours is 80 miles, 3 hours is 120, so that's 3 hours. 30 miles an hour, let's see, 30 is 1 hour, 2 hours is 60, 3 hours is 90, 4 hours is 120, so 4 hours. If I drove 20 miles an hour, let's see how many, here are my hours. So 20, 40, 60, 80, 100, 120. 120 miles is going to take me 6 hours. And if I drive 10 miles per hour, it's going to take me 10, 20, 40, 60, 80, 90, 100. Wait, did I do that? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 110, 120. So that's 10, and 2 more is 12 hours. So we've got to plot that data from question 1. So when my speed is 60, find 60. When my speed is 60, my time is 2. So find 2, match them up. When my speed is 40, my time is 3 hours. When my speed is 30, my time is 4 hours. When my time is 20, when my speed is 20, my time is 6. So speed 20 times 6 right there. When my speed is 10 miles an hour, my time is 12. So let's take a look at this. Is that constant or non-constant? Good, it's non-constant because it's curved. All right, so let's take a look at what they want us to do. Plot the data from question 1. Done. What is the relationship between the car's speed and the amount of time it takes to complete the trip? Well, we can say as the time increases, as the speed. As the speed gets bigger, as we go from 10 to 20 to 30 to 40 to 50 to 60, as the speed increases. So follow your lines. As my graph goes this way, what happens to my time? As I go left to right on my line, I come down in time. So as my speed increases, the time it took to complete the trip decreases. All right, we don't have to find the rate. That was a mistake on my part. All right, so as the speed gets bigger, the time it takes comes down. All right, on to your staying sharp. That was 3.3. Oh, we went over the staying sharp. All right, see you guys in class.